So this is the problem 3, practical kinematics 1. And the car travels in the circular path. So again, it will be a curvilinear motion. And the speed is increased. So similar to problem 2 that we have it before, by the acceleration at equal to 0.05 et meter per second. So that you can see in that case, the acceleration at have direct relationship with the time, not as like problem 2, and t in seconds of the time. And the question determine the magnitude of the velocity, so speed, and also the magnitude of acceleration after the car has traveled s equal to 80 meters. So this is basically s2, right? That will be the s2 there. And starting from rest, so we know the initial condition, v1 velocity from rest, so it will be 0, and s2 is 80 meters, so we can have that original s1 equals 0, so that one is given. And basically this problem, they say neglect the size of the car. So as you can see, in the reality, the car is a body, basically, not a particle. But in this case, we only see the motion, the general location of the car. So we can consider that is a particle, and we can ignore the size of the car in there. So like the previous 2 problem, we can start with the acceleration at equal to 0.5 et. You can see there. And because t, this is about time, so we can use directly without any transformation. So that's the difference from what we did in problem 2. So from at that, we can find out v velocity. We can take integral of at. So it's at dt, plug in, I can have 0.05 et dt. So from that integral, I can have 0.05 et dt is equal to et, right? Et. And then we need to add first in the constant, so that we can have it C1. So C1 will be determined from the initial condition. So in this case, we can say at t equals 0, so the initial condition, and the body starting from rest. So we have v1 equals 0. And from that, we plug into that equation. We can have 0 v equals 0 equal 0.05 E0 plus C1. And E0 is 1. So as you can see from that, I can have C1 equal to negative 0.5. So move 0.5 is basically equal to 1, right? This component, and move 0.5 to the other side become negative. So bottom line, we can have the velocity equation equal to 0.5 et negative 0.5. Let's make that the first equation. And then we can continue with the distance, because that they give us the s travel 80 meters. So we want to find out the equation with the distance as well. So we have v, so we take another integral to get s. So we can have s equal to v dt integral, and we can plug in 0.05 et minus 0.05 dt. And from this one, we can have s equal to 0.05 et, negative 0.5 dt, so it will be negative 0.5 t. And then we have to add a constant. In this case, I call C2. We have C1 above there. And C2 determine the constant determined from the initial condition. So we can get add initial condition t equals 0. We also have S1 equals 0. Put address there. So when we plug it in that equation, so what do we have is 0 equal to, that is S, right? S equals 0 and equal to 0.05 E 0 minus 0.05 0 plus C2. So from that we can have C2 again. This is 0.50 equals 0 and is power 0 equal 1. So on the other side, so we can have C2 again equal to negative 0.5. So we can rewrite the equation of the distance as equal to 0.05 et minus 0.5 t negative 0.05. So that's the equation in the relationship between the distance and the time, and we call that either equation number 2. And let's get back to the problem. What is given here, they give us the s equal to 18 meter. So add 2. So that you can see in this equation 2 unknowns, s and t. And now they give us s. So we can find out the time. So we can say add t. Sorry, add s, the distance, equal to 18 meter. So we can plug into that equation equal to 0.05 et. Let me write in another color there. Equal to 0.5 et 0.5 t negative 0.5. And this is one equation, one unknowns about time. And then you can solve, and of course E, so you can solve graphically or trial and errors. But in Canvas, we have how to solve with your calculator. So I suggest you to familiar with one. In this case, calculator will be the most efficient for your generation. So with that, I assume you can use your good calculator to solve this problem, this equation. Then with that, we can say solve the equation to get the time equal to 3.705 seconds. Okay, so that is the time. So what does that mean? It needs 3.705 seconds for the car travel 18 meters. And now go back to the question. The question asks what is the magnitude of its velocity and the acceleration, the magnitude of the acceleration. So we already have equation of v with the t at a independent variable, so we can plug in to find out v. So as you can see, v in this case v2, and after 18 meters travel or 3.705 seconds, so I can plug in, the equation is point oh point 5 et, right? Et, so we plug it in 3.705 minus 0.5. So that's the equation there, equation number 1. You see there? So plug it in, we get that one equal to 19.83 meter per second. And that basically the magnitude of the velocity or the speed. And more specifically, that either at the car travel 80 meters, so it s equal to 80 meters, and the time of course is going to be 3.705 seconds. And then the normal and the tangential components of acceleration we need to determine so that we can find out the magnitude of the total acceleration of the car. So similarly, we can find out the acceleration, two component, an and at. An equal to v over rho, and plug in v already have 19.83 square, 19.83 square over the radius, in this case 30 meter there. So plug in 30 meter. So from that we can get 13.11 meter per second square. That is the normal components. And tangent to the path, by the way. And then we can also have the tangential, this normal component, it will be directed to the center of the curvature at that instant. And then we have at equal to dv over dt. That is already given up here. The problem already gives us at equal 0.05 et. So we don't need to take the derivative. We can plug in what is given. So it will be 0.5 et. That is problem given. So we can plug in. We can have it 0.5 e 3.705, and it will be 20.33 meter per second square. So we have tangential components and the normal components of acceleration. The question asks what is the magnitude of acceleration. So you can find out the magnitude of acceleration. A equal to square root, right? Square root at square plus an square. Plug in those two numbers. At 20.33 square plus 13.11 square. From that you get 24.2 meter per second square, and that is the magnitude of acceleration, another answer. And with that we finish this problem.